Hi everyone, it's Miss Torres here. I hope everyone is doing well. Today I'm here to do a little science lesson with you, so let's go ahead and get started. Alright, so I have this ruler standing up straight here on this flat surface. Would you be able to tell me where the object's shadow would be? You might say that it depends on the position of the sun or other light source. So if you know the location of the light source in relation to an object like this ruler, where will its shadow be? The shadow will be on the side of the object away from the light source. Alright, let's go ahead and take a look at our focus question today. So what can be learned by studying the length and direction of shadows? In order to test this out, we are going to use something that is called a sun tracker. Before we get to use our sun tracker, let's go ahead and talk about something that's called a compass. A compass is an instrument containing a magnetized pointer which shows direction. Because Earth is also a magnet, the painted end of the needle will always point north. Even though you rotate the dial, the needle always points north. When you have oriented the compass, you can identify the other directions. The cardinal directions are north, east, south, and west. Let's go ahead and take both our compass and our sun tracker outside. Alright, so here I have my sun tracker and my compass. I have a golf tee glued into the center of my sun tracker. That's going to help us track the length of our shadow. I am going to align my needle so that the red tip is aligned with north. Now to record a shadow, I am going to mark the tip of the golf tee shadow with a dot like so, and I'm also going to record the time. I'm going to come back in an hour and observe what happens to the shadow. So what do you predict might happen to the sun's position and the shadow throughout the day? Here I am an hour later. Take a look at my shadow. What happened compared to the shadow at 8:30? I will check back again in an hour. And I was saying hi to my little ant friend there. This time around, I had a little helper, my dog Avery. You can see a shadow there. So an hour later, 10:30, there is my shadow. Now this is the last recording of the day, 12:30, and you can see that my shadow is really small in comparison to when we had first started at the beginning of the day. 12 o'clock noon is when the sun is at its highest point in the sky. As the afternoon goes on, my shadow will continue to get longer, just as it did at the beginning of the day. Alright, now to go back to our focus question. So what is the relationship between the position of the sun and the length and direction of shadows? From my observation, I noticed that shadows are longer in the early morning and late afternoon when the sun is lower in the sky. Shadow angles are evidence of a changing relationship between the position of the sun in the sky and objects that are on the ground. The direction of a shadow indicates the time of day. North is around noon, westward is morning, and eastward is afternoon. It's because of Earth's rotation that causes shadows to change direction and length. All right, friends, that's it for now. So until next time, please be safe, and I will talk to you soon. Bye.